Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. Peace be upon you guys. I hope you guys are doing well. And I'm thankful that you're back on my channel. And if this is your first time being here, welcome as well. So for this particular video, we have if the expression in the red box, -3 minus 2i divided by 2 plus 3i is written in the form a plus bi, where a and b are real numbers. What is the value of b? So what the question is asking us to do is the question in the red box, or the complex number in the red box, which is actually a fraction. So -3 minus 2i divided by 2 plus 3i, if that is written in the form a plus bi, and a and b are real numbers, we should find the value of b. So this is basically what the question asks us. But in order for us to get from a complex number fraction to a plus bi, what we have to do first is for us to solve it and simplify. So we're going to start doing that now. So you have -3 minus 2i divided by 2 plus 3i. The first thing you need to know is this. Anytime you have a question like this where the denominator has the imaginary number I, in this case 3i, that's the imaginary part of the entire complex number in the denominator, which is 2 plus 3i. So that's a complex number, but the imaginary part that is at the denominator is 3i. What you have to do is you're going to pretend that you're dealing with radicals. You know how, for example, if you were given the question 30 minus 25 radical, right, or 26 radical, divided by 42 plus 17, that is a radical, so like the square root of 17. Well, in order for you to solve this, if you guys remember, you're going to have 30 minus square root of 26 divided by 42 plus the square root of 17. But guess what? In order for you to solve it, you have to multiply by the opposite of the denominator, or the conjugate of the denominator. So multiply the numerator and the denominator by 42 minus the square root of 17 divided by 42 minus the square root of 17. So what you do is you're going to multiply the numerator, the two different numerator together, and the two different denominator together. So this is what you do when you deal with radicals. But guess what? We're going to do the exact same thing to this question. You don't only do that with radicals, you do that whenever you have a complex number or an imaginary number on the denominator of a question like this. So we're going to multiply the top and the bottom by the conjugate of the denominator. And the conjugate of the denominator is going to be 2 minus 3i, and then numerator as well, 2 minus 3i. So we're going to multiply. So you have -3, -2i, and 2 minus 3i divided by 2 plus 3i, right? And 2 minus 3i. That's literally it. So when you have this, you're going to FOIL the top and the bottom. Foiling is just the process of expansion, and foiling is a method that you use to expand. So we're going to deal with the first, the outers, the inners, and the leaders. And not the leaders, and the last. That's how you work with FOIL. So when we're dealing with the first, we have -3, the first of the of each one of the bracket. We have -3 and 2. Hence, we're going to have -3 times 2, same thing as -6. So that's the first. And then you have the outers, which is what is outermost. So in this case, it's -3 and -3i. So we're going to have here -3 times -3i, that's positive 9i. And then you have the inners, which is what is innermost when you look at both of the parentheses or both of the brackets. That is -2i times 2, so that is -4i. And then the last is just basically what is the last term in each one of the brackets. So that's -2 and negative 3i. When you multiply them together, you're going to get positive 6i squared. So we're going to do the same thing as we foil the numerator. We're going to be foiling the denominator. And I would advise that if you don't currently have a book with you, you should get a book, please, and write as I'm writing. So we're going to foil the denominator as well. So we're going to care about the first terms, and that is for the first terms in each one of the parentheses or brackets are 2 and 2. So 2 times 2, that's 4. So we're going to put a 4 here. And then the outers, so what is outermost when you look at both parentheses combined. So what is outermost in this side is 2. What is outermost in the other side is negative 3. So you're going to have 2 times negative 3, that's negative 6i. What is innermost would be, when you look at the entire parentheses, both of them combined, you have positive 3i and 2. So that is plus 6i, so 3 times 2. And then you have what is last. So what is last in each one of the parentheses, you've got 3i and negative 3i, so that's going to be negative 9i squared. So I'm going to continue with blue just so there's a difference between all that we're doing. So next thing we have to do is that we're going to group each one of our work, basically. So you have negative 6. That will be negative 6 by itself. So that's grouped by itself, a simple constant. You have 9i minus 4i. Actually, I'm going to write this in a better color, red. So negative 6, so that it's easier for you guys to see. So you've got negative 6. 9i minus 4i. It's just like saying 9x minus 4x. You're going to pretend I is a variable, even though we know I is an imaginary number. So that's going to be plus 5i and then plus 6i squared. Now, what do we know I squared to be? We know that I, first of all, is the square root of negative 1. So therefore, I squared is going to be equal to negative 1 in square root all squared. So I squared, let me rewrite this, equals to the square root of negative 1 all squared. That's the same thing as saying the square and the square root canceling out, because it's like saying negative 1 times negative 1, and each one of the negative 1 in a square root. So the square root of negative 1 multiplied by the square root of negative 1, that's just going to simply give you negative 1. So therefore, I squared equals negative 1. So that's that. So I'm just going to put that here. So that will be plus 6 times negative 1. Remember, we just did it in the previous page. And you can do it by the side of your notes. You pause this video and do it by the side of notes so you can confirm that I squared is the same thing as the square root of negative 1 times the square root of negative 1, which will give you just negative 1. So yeah, that was what we just did in the previous video. So you have the denominator, you have 4 minus 6 plus 6 is 0, so that will be 4. Minus 6 plus 6 is 0, so we don't have to write that down. Minus 9. What did we just say I square stands for? I square is negative 1 times negative 1. So we're going to rewrite what we just had there on the next page and continue solving. So you have 6 plus 5i plus 6 times negative 1 divided by 4 minus 9 times negative 1. So that is what you have so far. Yeah, that is literally what you have so far. So 6 plus 5i plus 6 times negative 1, same thing as 6 plus 5i minus 6 divided by 4 minus 9. So you have 6 minus 6 is 0, and up top you have 5 plus 5 plus, sorry, give me a second, I'm so sorry. Oh yeah, I see, I made a mistake, you guys. This is just all part of math. I missed it when I was transferring. I forgot a negative value, so I'm going to put a negative value here. So this is negative 6. That's part of math, so always try to look at your work again So that's negative 6 minus 6 is something that's just negative 12 plus 5i. And then 4 minus 9 is 4 plus 9, which is simply 13. So you end up with negative 12 plus 5i divided by 13, which is the same thing as saying negative 12 over 13. So that's the real part, plus 5 over 13i. So this part here is the imaginary part. I remember what the question asked us to do, you guys. It said we should put it in the form of a plus bi. So a plus bi, and we're supposed to find the value of b. And the value of b is 5 over, positive 5, by the way, 5 over 13i. Do not forget that, never forget your signs. Because if you had a question that had a negative in front of that, that could even make you miss it on the SATs when you're supposed to shade in the correct multiple choice answer. So our answer therefore for B is just going to be 5 over 13. And this is the answer to the question. So I wish you guys all the very best. Thank you so much for coming back to watch my SAT Math Prep series. I hope this imaginary complex number question has been easy for you guys to understand and think through. I try my possible best to break down the information, and make sure you guys keep on watching more questions on imaginary numbers and complex numbers, as well as all the SAT Math Prep series that is on this playlist and all the videos on the playlist. I wish you guys all the very best. If you have any questions, please put that in the comment section, and please keep watching the videos daily and do not give up, because it takes time. Assalamu alaikum wa rahmatullahi wa barakatuh.